All right, so I think we're going to get started. So thanks for everybody for coming in. My name is Pitt Fagan. I'm the organizer of the meetup, so I know a good number of you, but for those of you I haven't met, welcome. I'd like to, before I introduce the speakers, I have 3 announcements. One, I'd like to thank our sponsors. The food and drink here are provided by Cloudera. Cloudera actually has an individual here who works for Cloudera. His name is Brian Baylod, so thank you, Brian. Thank you, Cloudera. I'd also like to announce that one of our other sponsors is Hortonworks. Hortonworks is sponsoring a round of drinks that are going to happen immediately after the meetup. So if you want to have a round of drinks on Hortonworks, we always go over to the Ivory Room. That's literally half a block away. So just hang out for a couple minutes after the meetup ends, and we'll head over there. And we actually also have a representative from Hortonworks here named Mike Ellis. So Mike, thank you very much. So anyway, yeah, so the other 2 announcements. One, the very next meetup that we have for this meetup is actually next Thursday, or rather this Thursday, 2 days from now. Normally we don't like to compress things that dramatically, but we have a speaker flying in from Washington, D.C. And so the subject of that is sort of as part of our data science series. And she's talking about data science on Capitol Hill and how data scientists work inside of the federal government. So I hope you guys can make it. That'll be, I think, very interesting. The other announcement I wanted to make is Monday, August 22nd. Me and some other guys, including Brian, are organizing the 2016 Big Data Wisconsin Conference. It's the very first one we've done, kind of talking about the state of big data in the state of Wisconsin, and we hope that this will be the kickoff for larger events in subsequent years. It's being held right here, and then we also have the room next door. So room 301 and 302, we're shooting for about 150 people. Have a half-day series of presentations organized around different themes and different areas. So that's being held as part of the Forward Tech Fest. So for those of you who don't know, the Forward Tech Fest is a week-long, 8-9-day, I think, long series of events that are all throughout the city, primarily downtown, but all throughout the city. And we're one of the events on there. So that event, due to sponsors, is being offered free. So we're very excited to be able to give that free to everybody. So
registration for that?
Yes, I was just about to call it. So I'll send out another email about this subsequently, but the registration is through the Forward Tech Fest right now. So I'll send out a link to that. Basically, you just add that to your, quote, cart as a free meeting, and then that way we'll get a handle on the attendance. So thank you for bringing that up, David. Otherwise, I'd like to introduce our speakers. Obviously, this is Snowflake. This was, I think, originally scheduled for April, but had to be rescheduled.
That was Brad's wife's fault.
Brad's wife's fault.
Oh, that's right, yeah. We had another kid. Yeah, sorry about that.
Early.
No worries. So Snowflake, represented by 2 individuals here. This is Brad Ganas, who's the engineer who's going to be doing most of the talking, I guess. Yeah. And Carrie Geekus is over here, who set this up. So thank you, Carrie. Thanks. And then Dave Stamsta from CapSpeciality, who's over in Middleton, is going to be talking about sort of a use case of Snowflake that they have in their company. And then he's being joined remotely, we hope, by one of your colleagues in Denver. So we've never done sort of a remote call-in. It seemed to work preliminarily, but we'll keep our fingers crossed.
Is Ken on right now, actually?
Ken, are you there?
Yes, I am.
All right,
Hey.
great. All right, well, we'll hear from Ken later.
Technology.
With that, I'll turn it over.
Yeah, great.
Brad, thank you.
Great, thanks.
All right, so great to be here. Thanks for having us. It was so we did have our 4th child for April, so that's why sometimes this is the point of the day. Usually, start hitting the brick wall from being up all night with other kids, whatever. So if I lose my train of thought, carry you, Van, for 30 seconds till I get my stuff back. So again, I'm Brad Ganas. I'm with Snowflake. I joined Snowflake about a year ago, a little over a year ago now. I came over from Pivotal, where for the last few years I was working on Green Plum database as well as Pivotal HD and SQL on HDFS, and being part of the ODP when it was started, the Open Data Platform with Hortonworks and other companies and things like that. The last 18 years, in my whole career has been data warehousing, BI, and analytics. So for a long time I was on the services side, building data warehouses, doing the full continuum from requirements and analysis to the data modeling, to the ETL, to the reporting and everything in between, being a part of both successful and failure type stuff, and seeing what works and what doesn't has been interesting over the last several years. When I saw what Snowflake was doing, it popped up on our internal radar a year and a half or so ago when I was over at Pivotal. And usually when you start hearing about the new technologies, the pre-sales guys, the guys with their, the practitioners, the guys with their, hands on the keyboard, usually it comes up with, here's why this company sucks, and here's what they're not thinking of, and here's why they're going to fail. And when Snowflake popped up, though, we all kind of stopped because we're like, wait a second. if they could actually do that, that's actually compelling. And knowing some of the people that Snowflake had gotten on board to develop their stuff, people who were part of building out Impala, people who were part of Teradata stuff, industry veterans from all over that weren't just kids out of San Mateo in a garage thinking about new things for data management, but really industry veterans who've been around all of our data warehousing successes and woes over the last several years building this thing out. And when it popped up, when they called me and said, do you want to come over and help tell the story in the Midwest? I said, yeah, I heard about you guys and gave it a look, and I find it pretty compelling. In my 18 years, this is the coolest database I've worked with so far. So I like talking about it. I like showing it off. I don't necessarily want to fill up the whole time with just me talking, because left to my own devices, I can certainly do that. But I'd rather keep this, let's have a discussion. Let's talk about it. Let's talk about pros and cons. I think that's probably the best thing that comes out of these events is, hey, what are you doing? What did that save you? How does it compare with what I'm doing right now? And I think between both me and Dave talking, we can cover that and just get some good conversation going. So with that, that is the agenda here. So it's going to be me talking for a little bit. I just want to introduce Snowflake in a general sense, kind of set the table for how we're different from the other data warehouses, other appliances, other data platforms we've been using, and the things that have come to the fore for us over the last, I'll call it 7 to 10 years, and maybe in some cases a little bit longer. And I want to show Snowflake off live, right? How do you make a database sexy, right? Hopefully I can pique some interest for everyone here, but just by seeing what our database is capable of doing. I'm just curious, real quick show of hands here. How many people are they really got their hands on, the data warehousing, BI stuff in your places of work here? The DWBI folks, okay. Everyone else, anyone else looking at databases for any particular reason? Data Lake? Anyone interested in Data Lake? Everyone? Okay, and what's going on with that? Okay. Advanced analytics. Anyone looking at that? Okay, a couple more hands there. Okay, cool. All right, we'll leave it. I'm just curious. Anyone looking at Internet of Things? JSON, Avro, XML. How do I start writing SQL and getting analysis out of that type of stuff? Okay, got the spattering. Okay, cool. Should be a good conversation then. After I show Snowflake off, I'll hand it over to David Stamsta and Ken Wood over from CapSpecialty, one of our customers here in Madison, Middleton, right? I lump it all together. So that's right. It's like I'm from Oak Creek. It's just south of Milwaukee. It's Milwaukee, right? Just lump everything together. Yeah. So great. So let's get into it. So Snowflake. Who here has just even heard of Snowflake? Who's somewhat familiar? I know my sales guy is. I gotta hope so at this point. I got you trained just the way I like it. Is Snowflake brand new to everyone here? Okay.
And you mean the database, not the structure?
Thank you, excellent point. Snowflake database, not necessarily the Snowflake data model that none of us are supposed to have, but I guarantee everyone has at some point in some incarnation. Okay, so this is brand new to everyone. So Snowflake is an elastic data warehouse built specifically for the cloud. At the end of the day, we're a relational database, okay? But we were built and designed to overcome some of the things that we've been seeing over the last few years between some of the shortcomings of the MPP systems, the MPP shared nothing, Netezza, Teradata, Greenplum, systems, Oracle Exadata, things like that. But then also, some of the shortcomings that we see on the Hadoop side of things, right? As much as it wants to be a silver bullet, I think there's some really good use cases for Hadoop and HDFS. Structured, highly structured data is, I think, best in a database, and we want to bring the worlds of NoSQL and SQL together. But one of the themes I like to hit on with Snowflake is the word elastic. Anyone can scale. I mean, every customer or every product that you talk to, I guarantee somewhere in there, we scale. Scaling's easy. It goes in one direction, up and to the right, right? No one can ever come back down. And as we start entering the age of everyone wanting to kind of look at the cloud, is anyone here interested in what's going on in the cloud? Interested in that? Yeah, okay. You will be, trust me. You heard it here first. Cloud is coming to the fore as the de facto standard for where we're going to be doing our storage of data in our compute. Again, at the end of the day, I lost my train of thought on that. Yeah. So anyway, so we started not just being scalable but elastic, right? Can I go back down? I'm not always needing massive horsepower all the time. There are times where my system is idle, and if it is idle, if I'm not doing a lot of computational, heavy work right now, can I leverage a system to turn it off for a while so that I'm not incurring costs? In other words, can I pay on demand, right? Not just always thinking about capital expenditures. What do I think my max workload is going to be? And so we want to build a data warehouse designed specifically for the cloud. And so reading kind of left to right here, we built that database. So it's an all new SQL data warehouse database. So we are all new code. We didn't take MySQL or Postgres, some open source databases, and fork it into something that we think it should be, right? Something that's new and shiny. We didn't take any legacy code. We didn't take parts of the Hadoop ecosystem and build things on that where it's something else behind the scenes. It is all new code. Our founders literally sat down a few years ago and said, here's C, and let's start writing code from scratch. Now, it should be noted that, speaking of our founders, so 2 out of 3 of them come from Oracle. They worked there for 20, 22 years, something like that. These are the guys who are responsible for all the database tuning and optimization for Oracle RAC, database optimization. Between the two of them, they have over 120 patents in the database space. Our third founder, Marcin Zukowski, well-renowned in the database world. If you really get down into the weeds on databases, he invented vectorized query execution, which many databases then kind of take advantage of. He started his own company called VectorWise. It was one of the very first very large databases. That was bought by Actian, and then he sold that off, and now he's here too. So our founders, they've been in the database space for some time. They're all PhDs in this space. They want to write new code. What a lot of people were doing when we talk about the cloud is, and you're going to see more and more of this, people are saying, yeah, I'm gonna make it so that I can put Par Excel and put it into the cloud, or pick a database here that's going to be cloud enabled. And what they've done mostly is they make it really easy to provision a database, provision an instance of something or a cluster of something. Once it's installed and provisioned, though, you're still at the behest of some of the ceilings and thresholds that those systems usually still give you. And so while some companies were trying to just kind of buy the technology to do it, we decided, hey, let's sit down and build a database from scratch that takes advantage of the cloud. So designed for the cloud is the second one you see there. So rather than just taking some database and, hey, make it easy to click a button and here's my thing, we want to take advantage of these new parts of the cloud, particularly how we store data, and particularly, specifically, how do you start leveraging some of the free compute cycles, the free CPU cycles that we're getting, freeze in quotes, right, that we get in the cloud, but much cheaper now. And be elastic in how I bring it on and turn it off, and spin it up and spin it down. And then a very big one here on the third point is delivered as a service. So I think a lot of the big data ecosystems, for all the good they are, it does take some specialized skill set to install, configure, maintain some of these systems. We want to build a data warehouse that is near zero administration, but it's delivered as a service. Not infrastructure as a service where we're just, it's virtualized, hardware. Not platform as a service where here's the software, you just click a tile and, it installs from me, but I still have to manage everything. But truly software as a service where I go into an account, there's nothing for me to administer and maintain. We can talk more about that too, okay? A little bit about Snowflake's value proposition here. So, a few starting points that we see from various customers and why they're interested in this. One is one place for all the data. Diverse data in one system. I would say, we talk about the different kinds of data in our organizations. Obviously, we have structured data, that's table stakes, right? Everything that's in a varchar and integer and all that kind of stuff. We also have semi-structured data sets, right? I think XML, which has been around forever, right? But JSON, Avro, all the Internet of Things stuff is coming in those kinds of formats, and we have to start processing that and making good use of that data. So we want to be able to have a database that stores that as well. Then there's the unstructured data, right? And so unstructured for me, and for this conversation, will be, think of it as video and audio, things like that, right? And so with those three classifications, I think where Snowflake is saying, listen, we want to really extract some value is with both the structured and semi-structured data sets. In my travels over the last several years, I would say, the vast majority of data that I'm looking at with customers and prospects is structured and semi-structured data. And that's where Snowflake plays really well. And having one place for that is really key. Like I said, before I came over to Snowflake, I was over at Pivotal. And it was great telling the story to people like, hey, sometimes I want an MPP database for speed, but sometimes I want this HDFS Hadoop ecosystem for these semi-structured documents. And it's really cool because I can use Hive to be on top of Avro and extract out my stuff and put it into a flat file and then move it over to this server and then load it into a table over here, and now I'm looking at stuff together. And we said, look, why can't we just create a database that has all of those all in one, that really merges SQL and NoSQL type capabilities together? So in that regard, having the ability to bring semi-structured data, like JSON, into our database and just write ANSI standard SQL directly against it as is without having to pre-parse anything or anything like that is really compelling for a lot of our customers. And do so at scale. We store that kind of data in a columnar compressed way, and it's ultra fast. Right? Fast analytics, I think Carrie puts this really well. It's not just speed. I'm going to show you the speed. Right? We're proud of it. This is one of the fastest databases I've worked with on the data warehouse and BI side for ingesting data, and the fastest I've seen in terms of writing SQL. But not just that, but it's also time to value, right? Well, again, we're not spending tons of time with installation, configuration, tuning. All of that stuff falls away, which means it's more time spent on extracting value from our data sets, onboarding data sets right now. I want to extract value from it right now. I want to perform analytics right now, and do all that great stuff. So we have a customer, speed was a part of the POC, and afterwards we kind of, they invested in our technology, they love our stuff, and then we were invited on site. It was a couple months ago. It was the best meeting I've had in my career so far, where the customer said, you guys work exactly as advertised. Nothing was hidden. Everything works exactly how you said. And they gave us a whole litany of new things they were doing in terms of things that would have taken them 2 and 3 months to do. They did literally in a day or two to onboard data and get to analytics faster, which was really cool. This is a big reason why I came over from Pivotal to Snowflake. I didn't want to spend time on complex ecosystems anymore. I wanted to just write more SQL and do less tuning of configuration files and things like that. Zero management. So this one freaks people out at first. It freaked me out at first when I looked at it. I'm like, what do you mean zero management? No, there's no infrastructure. There's not knobs for tuning. There's none of that. There's no indexing. There's no partitioning. There's no, I'm not doing any vacuuming. I'm not worried about distribution keys, things like that. And when I first looked at it, I'm like, well, hold on a second. You're taking away my ability to look at explain plans and look for opportunities to get more performance and things like that. And then I thought, well, that's awesome. You're taking away my ability to have to look at explain plans and look for where distribution and broadcast events are happening. To me, that's not a value add part of analysis, right, on big data. And so we've really made a database here that I will say is near zero administration. And David, if you want, you can comment on that too later. But I really think we want people to do some table stakes stuff like role-based access and control. Who has access to what tables and views and objects and things like that? But on the infrastructure side, we really don't want you to have to worry about anything, okay? And then a fraction of the cost. We can talk about that. I do think that there are economies of scale in the cloud, right? The CPU cycles are becoming almost free. Storage is becoming much more cost-effective than on-premise, expensive databases and large HDFS clusters. The cloud just has some economies of scale there. So before any other solutions start, we don't have to worry about any of that. The software's already there. So out of the gate, you're seeing a lot of little cost savings. So with that, our database works with your existing tools. So one thing Snowflake is we're not the whole stack. We're not like a Microsoft SQL Server. When you buy it, there's also an ETL tool as a part of this, right? Does
it come with Excel?
What's that?
Does it come with Excel?
No. Everything in the world should come with Excel, just OEM'd into it, right? Since that's what everyone's using. But Bill Gates he's doing fine already anyway. But we're just the database, right? And what I like here is we said, listen, you've made investments in your ETL, data integration, BI tools for whatever reasons, right? You have your reasons. You've selected the tools that you like. As long as you can connect through, ODBC, JDBC, Python or Spark, we've made connectors for those so that those things can read Snowflake just fine, just like any other database, because that's what we are. It's just a database, right? And so, were there things here, Carrie, that? Oh, let me just come back here. Sorry. So, custom and packaged solutions. That's right. So, data management, transformation. Moving from left to right here, right? All the ETL tools that you see out in this space. MicroStrategy has been a great partner with us, and one of our first ones. And that's been great. We have a really nice story that you'll hear more about with MicroStrategy on top of Snowflake, hitting it directly and extracting really good performance, right? And then just a little bit about the architecture, just kind of have this come into focus a little bit. So this is a way to look at how our architecture is different from everything else out there. One of the biggest things is that what we've done is not just built a database in the cloud, but we've built a database that decouples storage from compute, which means I can dial the two separately. Some places are compute bound. In other words, I don't have a ton of data, but I'm doing lots of massive processing with lots of concurrency, right? That's one area. You have other people who say, listen, I'm not doing massive advanced analytics, but I do have literally 300 terabytes of data. I need a more cost-effective platform for storing that, right? So you're either storage or compute bound. And when you buy, these other platforms, MPP platforms, you're over-provisioning at some point, okay? Most of the time. And what we've done here is we've decoupled storage from compute, so you can dial them separately, which is very unique. And so what you see here is, does it show up there actually, Carrie? I can't tell from this angle. Oh yeah, okay. So in our system, we have databases. We have just your basic data. This is the minimum configuration, just a database. There's no necessarily compute around it, but I store data behind the scenes. We're storing it in S3 behind the scenes in AWS. We completely obfuscate, so I should say, we run an AWS, right? We are not married to AWS. That's just where the business is now, and they have the best infrastructure in terms of a storage platform and a compute platform. As other public clouds get better, we're looking at being able to put. There's nothing technically stopping us from putting this database in other clouds. But right now we're on AWS. But you're never working with AWS directly. We obfuscate everything, again, software as a service. But I'm pulling back the covers for you a little bit here. We store our data in S3, which is simple storage service, which is an excellent object storage layer in the cloud, right? And what you can have is not just storing structured data, but storing semi-structured data like JSON and XML and Avro. And what's different is I have these things called virtual warehouses, not to be confused with our databases, but virtual warehouse for us is just dumb compute clusters. That's all it is. And I can have any number of these dumb compute clusters of varying sizes throughout my ecosystem. So here I've got one here, I've got a user hitting this, using this compute to access the data here, right? I could have any number of users hitting that, and as more and more users hit that one cluster, they'll start competing for resources. But I can also, as it gets hit harder, I can spin up from like maybe a small to an extra large cluster, a 2-node to a 16 node. And I'll show you this too in the demo. On the fly, without stopping anything, I can just on the fly determine how much horsepower I want to throw at any workload that I have, right? And when I'm done with it, I can spin it back down. This is a huge thing. It'd be elastic, right? Let me go up, but then let me go down, right? Of course, I can turn things off too. I can say, listen, I'm done with this for now. And again, it skews the TCO in the customer's favor, so they have that. The other thing I can do here, again, this is a part of concurrency. This is probably one of the biggest problems to solve in MPP database and Hadoop land, which is how do I, as soon as I get data in my database, I get more and more users. How do I play around with things like resource queues and things like that to manage for concurrency? Who's most important on my on my query pipeline here, right? Who should get the most horsepower? Who should be prioritized? And how we're doing that, saying, listen, I can have different groups in the organization have have their own. Let me just build it out here. Have their own little compute clusters of, again, based on your SLAs of varying sizes. And a part of your JDBC ODBC connection then is it's like you're the only one on the database because no one's competing for the compute anymore. We can all be looking at the same database at the same table at the same time. It's like you're the only one on it. And we're fully ACID as well, so which is really cool because now as I have like some cluster that I'm using for ETL, I can still have people querying using a different cluster. They're not competing for resources. And they're not going to see any of that data that's being loaded until that stuff is committed and done. So you don't have to worry about in-flight, numbers changing, things like that, and eventual consistency, right? So we've managed that as well. And again, we have the connectors for Spark and Node.js and Python because they're so popular now. It is interesting. So when I started my career in the mid to late 90s, everyone was getting away from writing PL SQL, even though I love PL SQL, but everyone was getting away from spaghetti code to start, looking at, commercial off-the-shelf, packaged ETL offerings, and Informatica and Data Stage all came to the fore for years. And now it's funny because now, with everyone coming out of college now, everyone knows Python, and we have much more expressive languages, and everyone's trying to get away from those packaged solutions and go back to writing code, which is weird for me. I'm like, I thought we made it easier already, right? I didn't want to go back to writing code, but it can be done very efficiently. But this is the kind of model here. I'll pause for a second, see if there's any questions on this. Interested? We'll see what questions we have after I run the demo real quick. So again, one of the things that we're touting here, no data silos, right? Storage is decoupled from compute. Any data, again, structured or semi-structured. A data lake story is still intact here because I can query not just across tables and views and schemas, but across databases, across Snowflake databases. So as I onboard data, I don't want to have to worry about getting everything into an old star schema and think about that whole 9, 10, 12, 18-month process. I just want to onboard data, extract insight from it, start bringing different data sets together on the fly. As I find the juicy nuggets of information, certainly operationalize that into a star schema, make sure that only people have access to that. Sky's the limit on how you do it, right? Low cost. Cloning is something that I'm going to show you guys. That's actually one of my favorite features, is how we clone. It is very, it brings tears of joy to my eyes still because it would have saved me weekends back when I was developing stuff. But anyway, and 11 nines of durability. Again, because we're in the cloud, the internet's not running out of disk space anytime soon. When we actually load data into Snowflake, it's synchronously replicated across 3 different availability zones, 3 different data centers in AWS. So you would not lose data. It would take literally, the western third of the United States falling into the ocean for you to lose data. At which point, there's probably bigger problems in the world other than the database. But a very, very strong, durable model. Okay. Real quick about the architecture here, I kind of let you know some of it already. But again, we are in AWS, and I like to read this from the bottom up. Okay. So at the bottom here, we've got where do you store the data? The database storage is in S3, right? It's in utilizing AWS's S3 model here to store things. It's just object storage, right? It's I put data in, it expands. When I take data out, it shrinks, right? Again, I don't think we're going to run out of disk space. S3 is not going to run out of space anytime soon. So I don't have to worry about provisioning disk volumes anymore with certain amounts of space or things like that. Right above that is our decoupled compute layer. So I'm using EC2 for that in the AWS ecosystem. And we're having the two talk to one another, which is really interesting. And we've engineered around some of the difficulties in doing that. And so every one of these, I can have various compute clusters. Every one of these clusters has its own compute, its own size. We do utilize some result set caching as a technique for faster performance, and we can talk a little bit about that. But the thing that really brings this together, it's not that you ever hit it directly or have to do anything with it directly, but above this is our EC2 and the kind of the brains of Snowflake here, our global services layer, right? So we utilize EC2 and elastic block storage as a way to handle security and metadata and just handle all the infrastructure for you. This is the brains of our operation that brings and orchestrates those bottom two layers together, S3 and EC2, right? So you never have to really do anything, but that's how we're doing it. It's a continuous delivery model, just like Facebook today. Facebook made 3 or 4 updates today that nobody knows about. They don't go down, right? It's just continuous delivery. And we deliver this in the same way. There's no outages. There's no, when you have to patch something, you don't have to take an outage or anything like that. It's just there. Everyone's always on the same version. Okay.
Is there any ephemeral disk in that model?
The disk is actually, the only disk we have is disk that's on the EC2, instances. There is some disk-based cache that we
So you'd have some ephemeral disk there?
Yes.
Okay.
Yes.
No one ever makes mistakes.
People make mistakes all the time. I'm going to show you how. So one point here. I don't know if this is where you're going with it. So two things. People make mistakes all the time, and I'm going to show you how you get out of those mistakes because I've been guilty of those in the past. The other thing to note is that because we're in the cloud, these are when you spin these up as a customer, you're not sharing these EC2 instances, these VMs, with anyone else. There's no multi-tenancy there. When you spin up a cluster, it is your cluster. No one else has access to it. You're not sharing it behind the scenes with anyone else. You're not just being blocked off or firewalled off from it. It is dedicated to you, which is important. Okay? So with that, Snowflake in action. A couple things I just want to show you. I'm going to show you some ultra-fast, how do I load data? Again, zero tuning. Elastically scaling compute resources on the fly. I do want to show you zero copy clones because that means a lot, particularly when we start talking about data lakes and things like that and what this means. And talk a little bit about time travel, which is kind of cool. Actually, it's very cool how we actually do that. I shouldn't downplay that. It's the one thing that would have saved me some embarrassment in the past. Anyway. And then talk a little bit about querying semi-structured data like JSON and things like that. Cool? All right, so with that, I'm going to, Carrie, how are we doing on time? We good?
Probably a better question for Kit. How are we doing?
How much time do I have?
Yeah, no, we're good.
How much time do I have? 15, 20 minutes?
Yeah, you have, theoretically, you have until 8:45.
I'm not going to just make, okay, fine. Okay, good. We're good. So let me, and Carrie, where did my, I'm actually using Carrie's, oh, here we go. I got it. Sorry. There we go. Using Carrie's computer here. The beauty of the cloud. I don't have to worry about which desktop I'm using, right? I just have to give them my scripts that I'm going to use here in a little bit. So, let me just make this go away here. So, this is the Snowflake user interface, and I'm going to make it just a little bit bigger here. Just give myself some real estate so you can see it. One of the things I'd like to point out is that when you go to Snowflake, I mean, it's a crisp, clean interface. And again, I'll let our friends at CapSpecialty talk more about it. there's not a lot of hidden menus and submenus and configuration screens and stuff that I'm doing in the command line or anything like that. It's just, it's a nice clean interface that you can learn, inside of an hour, literally. I'm on this tab here called warehouses, and again, warehouses is synonymous with just dumb compute nodes, dumb compute clusters that I have, right? Right now I don't have any. I'm gonna have to create some in order to load data and query data, and that's all I need it for. But I don't have any right now, the meter's not running on them, right? But we're gonna create some here in a little bit, and I'll show you that. Before I do that, I'm just gonna go to this databases tab. Databases are where we have our databases, right? It's pretty simple. I've got an AppLog database here that's housing some JSON data, as well as another database here called sales that has, all the usual suspects of some tables here, a line item table and, orders and supplier and customer and region, all that good stuff. Yeah, question?
Why do you break that out from warehouse?
So again, warehouses, in our parlance, in our syntax, it's not your data warehouse. We call them virtual warehouses. They're just dumb compute clusters. That's all they are.
They're shared nothing MPP compute engines.
Yes. Okay.
Shared nothing cache.
The warehouses and the database together, that's your data warehouse, right? That's your marts and warehouses, things like that. But it's just compute, and that's how we break that out there, right? So databases are your actual, your DDL, your data definition of various, databases and tables and schemas and views and things like that, right?
You can query across them, join across them.
I can join across actual databases too. So database.schema.table and .object.
So under the covers, warehouses is EC2 and databases is S3.
Correct. Yep. And so, I've got, some seed data that I have in here. I got the line item table has 5,000 records. And I can see the size after compression here of some of this stuff. I'm gonna load just shy of 1 billion records worth of data across all of these records here, okay? Before I do that, again, we are a database. We're a relational database. So I have all the things that you would expect, right? I've got views. They're not materialized views, they're just regular views that we have. We have schemas like you would expect in any database. We have sequences like you would expect in any database. What is germane to us is we have these things called stages. And so a stage for us is really just a pointer out to a private S3 bucket from which I want to load some data maybe. Maybe I have some CSV or JSON data out in a private S3 bucket in AWS, and I want to load it into my database. I'm going to be using the sales stage to actually load all of this data. That's where I have all of these, flat files right now sitting out there to load, okay? I'm also going to load some JSON data too that we can take a look at. So that's all this is. No, okay. And then these things called file formats, and again, I can have any number of file formats here. I kind of hijack the name CSV. I can call it whatever I want. I can just say create a new file format, call it whatever I want, and then here's where I'm deciding, hey, is this a CSV or is it JSON or XML or Avro? What am I loading here? And as I change the options, I get different configuration options here. When it's CSV, I'm selecting, hey, what's the column separator and the date masking and all that stuff. Yeah, question?
How extensible is that? Do you have 5 options off the bat?
Do we have, I'm sorry?
So in that drop down,
Yeah.
the formats and everything, do you have 5 or maybe 4?
CSV, JSON, XML, and Avro.
Is that?
There will be more coming.
What's that?
There will be more coming, actually. Yeah. Probably one of the big ones is, can I say or no?
Yeah, go ahead.
Yeah, Parquet. A lot of our customers are saying, hey, I just want to ingest data directly from HDFS to put it in here. It reached critical mass to the point where it bubbled up in terms of priorities, and so we're looking at that right now. Okay. So, but that's it. That's all the sections here of managing your database stuff. So again, let's load some data. I want to load these tables here. So to do that, I need some compute. So I'm in the cloud. It should be easy to just spin some stuff up. I'm going to go to my warehouses tab. Again, I don't see that I have any clusters here. I'm going to create a cluster. I'm going to call this my ETL warehouse. And then I have a few configuration options. One is the type of server that I want to use, and we give you choice between enterprise and standard. For our conversation today, I'm just going to tell you 99% of the time you're going to use standard. If we want to talk about enterprise later, we can. In terms of size then, so we give people t-shirt sizes. In other words, how many nodes do I want in my cluster? How big of a cluster do I want? Extra small would be 1 node, small is 2, medium is 4, and then 8, 16, 32, 64, I can go to 128 and 256, but we will ask you why you want that many nodes in one cluster. Again, one of the huge, and we do have customers that we have one customer that has a 256 node cluster for a very special use case. They have literally, was it 2 petabytes of?
Yeah, before compression.
Before compression of
Columnar compressed database.
yeah, of JSON data.
JSON.
Yeah.
One database.
One database, right. Most of our customers are pretty pleasantly surprised with what they see out of even our small cluster, and maybe we can talk a little bit more about that too. For now, I'm going to use a medium cluster, just a little 4-node cluster here. A very subtle but important part of our solution here too, again, is that we have an auto-suspend and an auto-resume feature in our database. So everywhere else in the cloud, once I provision something, whether I'm using it or not, I'm being charged, right? The meter's running. And here, what we're saying here is, listen, after X amount of time, if no one has written any SQL, no one's trying to connect to this thing, whatever it might be, let's just be smart. If no one's using it, let's turn off the compute. Let's suspend it, and turns off the meter for you. Use the TCO in the customer's favor. The bookend to that is auto-resume. So if I've got an ETL tool like MicroStrategy that then connects to the database, and part of the connection string is using a certain cluster, and that cluster happens to be suspended, that will just automatically wake it up, and that's 1 to 2 seconds. The report doesn't even notice it really, right? That's it. I'll hit finish, and I just created a little 4-node cluster with which I can use to load some data. Okay. So to load some data, a lot of ways to do this. One of the ways I'm going to show here is I'm going to go to my worksheet tab. It's a very SQL workbench kind of type, worksheet interface here. I'm just going to load up a little script that I have here that I put on Carrie's desktop.
Go all the way down to the vignettes. Down the
Vignettes. Where did you do it? MacBook Pro. I'm the technical guy. Yeah. It's on your desktop, right? Oh, there we go. Okay, cool. Thank you. And so I'm going to bring up a little script that I have locally here, actually called Load and Report. Is that the first one? Yeah, Load and Report. All this is a SQL file that's local on my desktop here, right? Nothing special to it. I'm not going to walk through what this entire script is doing line by line, okay? We're doing just a couple main things. Number one, I've got a section of statements here, of copy statements. It's ANSI SQL copy statements that are going to load data. So all of this stuff, obviously every statement that I run here is going to run sequentially, but these copy statements will take advantage of parallelism based on the size of the cluster. So for example, I can copy into my nation table from that sales stage that I have, which is pointing out to a private S3 bucket out there. It's going to look at the nation folder and all the files underneath it. And oh, by the way, everything in there is going to be of this CSV format so that it knows how to parse it, right? And it'll take advantage of the parallelism to actually load that. And it'll run through each one of these to load, again, about 840, 860 million records across all those tables. And then after that, I've got a series of 22 different queries down here. Just of varying complexity, sophistication, just to show that we're ANSI SQL, we're doing with clauses, we're doing subselects, we're even doing, let's see, I got some windowing functions down here that I'm doing. Just bring it up over here. Yeah, I got a rank function that I'm doing over here, partitioning it over, things like that. We're ANSI SQL, not kind of, sort of like SQL, ANSI standard SQL, right? I can do updates and row level deletes and things like that because it is a database. So I'm just going to stop up here. I'm just going to hit execute all, and everything. Bless you.
Thank you.
And what you'll see over on the right-hand side now, and I will give myself a little more real estate, is you'll see that as it's running these statements, I can see the size of the cluster I'm using, the duration, the number of rows I loaded, things like that, right? I can decide now, say, listen, I want this to get done faster today. So I can, on the fly, say, listen, I want to use a bigger warehouse, a bigger cluster. Let's use an extra large. So 4x more the amount of compute to do it. So I move from a medium to an extra large. And what you'll see happen here is that it'll finish the statement that it was currently on, right? But the next statement that it starts, the next transaction it starts here, we'll be using, and there it is, an extra large cluster. And you'll see near linear scalability. So for example, I loaded 20 million records in 9.9 seconds on a medium, 15 million records in 9.4, and then on an extra large, I loaded 80 million records in the same amount of time, so 4x, right? It's pretty much near linear scalability. I loaded 150 million records into this orders table in 13 seconds. I'm now loading this line item table, which I happen to know is 600 million records, and it's about 18% of the way through. Actually, it's probably a little bit more. It'll be done in about 30 some seconds. So it loads pretty fast. Again, I went up to an extra large cluster, so I have more aggregate throughput coming in, right? And when I'm done with it, I can spin it back down. Cool, not cool? Impressive? Anyone want to call and be like, oh, that sucks. Yeah, I can do that better. This is pretty strong. Okay. Now, while it's loading this data here, and we're just about done with that 600 million records, then it's going to move on to do some other queries. While it's doing that, I want to show you that from a developer perspective, probably my tied for favorite feature, and that is the zero copy clones that we have. So, I think back to, and let me just look at the, excuse me, the database here. Let me just resort this. I now see that I have 600 million rows, 150 million rows, 80 million rows in these tables here that I loaded. Now, I think back to my developer days of doing dev, test, prod, QA environments, keeping them in sync with one another. It sucked sometimes, right? Or the age-old, hey, I need a sandbox to do some work over here, right? On all these different data sets. And after a while, it doesn't take long before the DBAs are just inundated with just piles of data marts and databases and instances out there. Like, who's using what for what? I got to recapture some of this stuff. It's a bit of a pain. Yeah, question?
Your time zone seemed to be off.
My what?
Was created an hour ago?
Yes, our AWS service is in Oregon. We are based in Oregon, yes.
It's part of time travel.
Yeah, right. Yes, absolutely. I can adjust that though. I can actually adjust this. This is an account level parameter that I can change. I can make it East Coast if I want. If it gives you warm fuzzies, right? That's cool. No, totally do that. Astute though. So the zero copy clones, right? What I want to do is I can clone a table view, schema, or whole database. So I'll actually come back to my databases tab here. And I'm just going to hit clone, and I'll call this like my sales clone here. Sales clone. Hit finish, and in a matter of a few seconds, maybe 5 or 6 seconds, it will have cloned that entire database. And so when I look at it, I open it up. There's all my data in it. Now, I didn't duplicate any data, so I'm not incurring any more storage costs. I didn't move any data, so that didn't take me any time. It is a metadata copy that we keep track of. And so, but it is a separate database altogether. So for example, I can do things like this now. I've cloned it, like, hey, I want to borrow so-and-so's, assuming you have rights to do it, right? I want to clone your data set because I want to do some stuff of my own on it, right? Do some dev work or whatever, right? But you know what, I don't need the 600 million record table, so I'm gonna drop that. And I'm gonna get rid of this 150 million record table. I don't need that one, and I don't need this 80 million record table. Let's get rid of that one. I need these other tables, right? Now, even though I dropped those from the database, I can still go back to databases here, right? And if I look at my sales clone, surprise, surprise, right? All of my data is still here. The fact is, the two databases are sharing stuff wherever they can. Now, I can take this a step further, like beyond just dropping objects. Well, I'll get to that in a second. I can do inserts, updates, and deletes on any of the tables here, and it will not propagate through to the clone, and vice versa. They are completely separate. Where they do start to diverge, you will get incrementally, more storage on one versus the other. But that's a sliver compared to the traditional mindset of the last couple of years has been, hey, let's just use, cheap hardware, and I can have triplicates and quadruplicates of data because it's okay now because it's where I'm storing it cheap, right? This is a different way of saying, listen, let's capture the data once, clone it. If I can still do good old CTAS, right? Create table as, select from, or create table and insert into, select from. I can still do that, right? But this cloning becomes a very nice feature for backups and snapshots and things like that in perpetuity without incurring a duplicate of the data, right? And for some organizations that have huge volumes of data and that don't want to pay for data domain or some other expensive backup solution, it becomes a nice thing to have over time. Okay. Question? Yeah.
So do you rely and then on, and you mentioned backups, do you rely on AWS as sort of backup machine?
I'm sorry, do I rely on what?
AWS to sort of back up into, backup.
So
to content?
we rely on AWS certainly, but backup and AJ, thank you, are built into the solution inherently in this infrastructure. And I'm going to show you that in a second here. So for example,
We're not like incrementally kicking off snapshots
Yeah.
in an interval or anything like that. We're actually, you can recover at any point in time and Brad will show that.
yeah, let's do it now. So one real quick thing here. What happens when I do things like, give myself a little more real estate here. Good old select count star from line item. Instantaneous response, right? When I was interviewing with my now boss, I said, well, that's cheating. Come on, you're looking at table stats. Force it to do a full table scan on some data on line item here, and let's see what it's coming back with. And so let's do that, right? I can do like L_ship mode, which is a column that I happen to know is in that database, or in that table, I should say. Not indexed, nothing's partitioned, nothing's in memory, nothing up my sleeve. We didn't do anything here, but I do, group by one here, ANSI SQL, right? I don't have to mention the column names here. But I'll run that, I'm done, right? It just scanned through 600 million records. Now, that was on an extra large 16 node cluster. You can say, well, listen, select count star from a table. I don't need 16 node, I don't need a big extra large cluster to do that type of work. And great, right? Then what I can do is I can just resize this, say, listen, for this kind of workload, let's spin back down to a medium, which costs me less dollars per hour, right? Finish, and now I can run that on, on a medium cluster. And when I do that, I run it, and instead of taking, whoops, there we go. Instead of taking, 826 milliseconds, it took 2.8 seconds, right? Near linear scalability. Okay. Now, back to the DR and part of the discussion here. So disaster recovery. So what happens when you do things like this? Drop table line item, that 600 million record table, right? I run this, it's gone, line item successfully dropped.
Oops.
Yeah, it's gone. And then you start running queries on this again. Line item doesn't exist. This is usually the old crap moment. Like, oh my God, I was in prod, I wasn't in dev. Not that any of us have ever done that. I know I have. It was a rough day at a pharmaceutical company out east when I deleted 3/4 worth of their financial data warehouse stuff. That was a crappy call I had to make to the DBA. And to my boss, like, look, this is what I did tonight, all right? I'm sorry. I was on a roll. I didn't see what window I was in, all right? Now, what's nice is that when you have those moments, because of the architecture that we've chosen, I can just do things like this. Undrop table, line item, and it's back. I have 24 hours with which to do this, right? And of course, now when I run my data or run my query, it's going to run again now, right? Using that medium-sized cluster there. And again, it scanned 600 million rows in 2.1 seconds to do it.
How come the times are local now?
Times are local now. 7:04.
Well, that other time it said created. Maybe it was created back then.
Yes.
Did you spin up
You know
your
what?
demo
Damn
copy
it,
background?
you guys are actually paying attention? Oh my God. All right, now I can't, okay, I better be careful
So it's
now.
important to note that time travel, so like with our standard level of service, our entry level offering, it's 24 hours out of the box, and then our enterprise level service offers 90 days
Yeah.
worth of time travel. And again,
Yeah.
that's not to like a point in time snapshot, that's down to the millisecond, any point in time within that retention period.
Last refresh time, interesting. Now it is local.
As our customer, there's no
Earlier it
tricks
was-
up our sleeve.
It
Yeah,
was local up there,
He's
but
telling
you.
not.
Yeah.
It's
Anyway.
not creation time.
I'll look at that later. So, I'm sorry, question?
No, I was just saying, like, ask Dave, our customer,
Oh.
there's no tricks on our side.
Yeah,
right.
This is a live demo.
Yeah, that's right, yeah. So the undrop is cool. I'll take, again, I can undrop a whole database, a whole schema, tables, views, whatever. I can go, again, a step further than that. What happens when I truncate data? That's a little bit different than just dropping an object. What happens when I truncate data or update data, right? Now I'm changing it. And so I have something called time travel here where I can select from a table at a moment in time. So I can select from line item as it was at 1:14 p.m. and 29 seconds on May 23rd, right, if I want to. We can go up to 90 days to do that. It's like DVR for your database, okay? And so I did a version of that down here. So when I first loaded all of this data, one of the other SQL statements that it ran afterwards was this one. Let me find it down in the list here. I think it's right over here somewhere. Show the records before and after. Here we go. So this SQL statement that I ran was basically saying, hey, select account star from line item as it was 2 minutes ago before I started doing the ETL. And select account star from line item as it is now after I loaded everything. And so I can see the results at here of the different record counts, that 5,000 records and 600 million records. Obviously, I can select the actual elements in there, right? So again, this is not to replace good old type 2 dimensional modeling capabilities per se. This is more of a disaster recovery type scenario when, hey, I did some ETL, some integration, I screwed something up, I want to go back to how it was at a moment in time, or as of X minutes ago, or as of a query ID, back to what it was at a state where I want, right? This is really cool. This is baked in, this is not extra. This is just a part of the architecture that's available in the cloud now that we used to not have when we had on-premise databases, right? It's baked in. I don't have another cluster with which to always do things on, things like that. Okay. Any questions on that? Yeah.
So could you presumably, reset to that point in time?
Yeah.
Yeah, restore the table. So this happened to us just a few weeks ago.
Okay, there you
Yeah,
go.
real sorry, we load every day, and for some reason, the CSV file didn't make it up, so the table got loaded empty.
Sure,
And
okay.
Yeah, I walk in,
Yeah,
like,
right.
what do I
Now
do?
referential integrity
So
now, right?
I
Yeah.
knew about time travel, but I just went to the help and restore from time travel, and I found the syntax and
Yeah.
put the table back the
Yeah.
way it was before it was loaded, so.
So you knew the time, but can you use named transactions? Please.
Actually, yes. So if I can go to my history here,
Great question.
I can see my history, and a part of my history is the query ID. I'm selecting one here, right? Here's where I did the undrop, right? But I can find which statement I ran that I know, hey, this is the thing that screwed it up. I can look at the query ID here, and I can do create table as, or however I want to do it. There's a couple ways to do it, right? But I can select from a table as of that query ID.
So if the application names transactions, then you can go to that.
That's essentially how they do it, yes. Cool? All right.
So when you truncate table, for instance, you're not really releasing that storage because you still have to persist it on S3, so you're still paying for that storage until this retention period ends?
That is a great question. Very astute, yes. And so the answer is yes, okay? One of the things that we do automatically is we have something called fail-safe in our system. And it's something that Snowflake does behind the scenes to do that exactly that. So when I actually truncate data, right? This is different from time travel, but I keep that data so after it's deleted and truncated, whatever, I still keep it for 7 days. Snowflake, I should say, not me. They won't let me touch the data. It'll keep for 7 days. So it accounts for if an absolute disaster were to happen, if somebody figures out a way to completely hack AWS S3 and screw up all their blocks, or a Snowflake employee goes absolutely berserk one day, this is a way where we have that data back for X amount of time. Now, your point is really relevant because now as I'm doing a lot of create and drop, that's more and more storage I'm building up and keeping along for a while. So we do have the idea of transient databases, transient tables, things like that. And essentially what they are is they are like temporary tables that persist across sessions. We have time tables too. but it doesn't include itself in fail-safe. So for dev environments, or for stuff that you know you can get back really quick, I say, use transient tables for that. That way you don't have to worry about building up more and more storage. I don't know if that's where you were going or not, but I think that's where you were going with realizing that you're keeping that retention around. We've thought about that. We want to keep that friendly to folks. Certainly if it's production, yeah, I mean, it's a cost that we're incurring that we've baked into the solution, right, to keep it around so that you would not lose data. It's one of the many things we do, right? But there are also some times where you're just doing dev stuff and you're like, I don't care, right? And I can get the data back. If I lost it, it wouldn't be the worst thing in the world. There's ways to alleviate that too, to be friendly. Yeah. Okay. So one other thing here, the last thing I'm going to show, and then we'll turn over to questions and then keep moving along here. We can always come back to stuff too. I suppose I should have this brought up already again. Late in the day for me. Changing diapers at 3 and 5:30 in the morning. Okay. I'm going to log into this other person here.
You want me to do the rest of the demo?
Yeah, you know what? As soon as my sales guy learns how to do the demo, man, that would be great. Just call me if you need me.
I'm watch your YouTube.
Yeah. So let me just create a little cluster here real quick. I'll call this like my campaign. Campaign warehouse. Standard is fine. I'll just make it a large cluster. That's fine. Finish. I just spun up a large cluster. I'm going to go to my worksheet tab, and I'm going to load up a local file that I have here again. This one's going to be called campaign analysis. Now, I'm going to explain what it's doing while I'm actually running it here. Hit execute all. So this is a scenario here where I've got some Twitter data. Everyone wants to look at Twitter data and LinkedIn data, just anything JSON, right? Twitter data comes in JSON format. And so we have some databases where we're taking in some of that data in somewhat micro batch real time. And we're storing it here. Now, the scenario in these SQL statements that I'm going to run here is that, hey, I've got a database that has a table that's storing Twitter data as is in its raw JSON format. And of course, I've got that other database of sales where I've got line item with 600 million records and just a whole bunch of records across all that. And what if I want to bring them together, right? And so one of the things we're doing here is first I've got this schema here. So describe my table called tweets that I've created. And if I do that, I see that I've got two columns down here. One is a timestamp, right? No big deal. But I've also got this column called tweet and the data type of variant. Variant is a new data type that we've created, right? It's a patent that we have that allows us to store JSON as is. So for example, if I just want to, whoops, not that one. It's running fast here. Just come down here a second. Display, here we go, display the last available tweet. So I've got this SQL statement that's looking at this other table that I have called tweets last day to just go get the latest tweet that I had. If there's any cursing in here, I apologize. This is live data from about 41 seconds ago, pretty recent here. Carrie and I did our first one a few weeks ago where I've done this, over 100 times for us. It's all pretty benign. We did get a tweet that was just littered with curse words. I heard stories about that happening, and it just didn't happen to me. I'm like, it doesn't happen. No, it happens. So if there's anything in here. But this is how we're actually, let me just, again, real estate here. This is how we're actually storing, oops. Let me just move this over here. Let me do this. No. There we go. This will be a little better. No, I'll just come up here. All right.
I don't think this is the first.
So, here's the actual tweet. This is how we're storing the data as is. Think of our variant column as again, gross oversimplification, but it is a very, very sophisticated cloud field, right? That allows me to write SQL directly against the elements of this document. So I've got, contributors and coordinates and entities and hashtags. And when I run into elements that have arrays, we've actually extended our SQL to do a lateral flatten. So I can take arrays that are in my JSON and vertical decomposition, right? Turn them into rows, which is really cool, right? Then I can just, query all the elements of this stuff in here. This one's pretty benign. There's nothing really in here. Okay, cool. All that good stuff. So that's how we're storing JSON data in a table as is, right? Just like that. And what this SQL statement was doing, again, just to show here, we're ANSI SQL. I'm using a with clause to actually do the first part of the SQL statement to say, hey, and notice the syntax here. I'm going after database.schema.table, right? So I can bring a whole bunch of different Snowflake databases together, right? And join on them. But I'm going to get, for every day in January for this product, go get some sales data. And I've got another part of this with clause that's actually going after, from tweets here, where I'm going after the entities and hashtags element, and I'm flattening that out here, turning those that array into rows here, and again for blue sky, and for every day in January for that product. I'm using a dot notation, which is relatively easy to learn. Just using a dot notation to walk through the elements of a document. It doesn't matter how deep the nesting is. I can do that though, right? And that's all this is doing to bring that together here. That ran in, let me see here. That ran in 59 seconds to scan 50 gig worth of data. Here's the resulting set down here, 30 rows, things like that. Okay. Another thing that I'll just show you here, I'm gonna come into, Carrie gets nervous when I go off script for stuff.
So when you can create a view, right? And
I'm gonna show that. I'm gonna show it. I didn't tell you I was gonna do this. This is something I created a YouTube video for doing this, for what I call our JSON challenge here. I'm just gonna log in. This is an account we have with my colleagues. We kind of share a system here for testing stuff, things like that. So this is our environment here, right? So I've got, again, I'm on the warehouses tab, a whole bunch of clusters of varying sizes here that I have with my colleagues. I got this extra small cluster. I'm actually gonna resume this. I'm gonna use an extra large just to get stuff done now. I'll incur some cost for Snowflake. You can ding me later on that. Okay, and of course, today's the day when it's gonna actually be,
this is good for the demo.
Yeah, it's good for the, yeah.
So we have an SLA with Amazon, like worst case scenario, it should take 5 minutes to or resume a cluster, or that elastic scaling. Usually it's 1 to 2 seconds like it did before, or it's like 2.5 minutes. Our SLA with Amazon is 5 minutes.
Yeah. So just to show off JSON for those of you who might be interested in what the database can do with this, now I'm gonna start handing it over here. I have a data set here. This is all completely made up data. I use the JSON generator to create this, but I've got 4,990, I don't know why I didn't make it 5,000. I think it was zero base, but 4,999 JSON files. Each file has 1,000 records, and each one of those records, it's not a terribly big one, but it does have a varying number of arrays, an array with a varying number of elements in it, and that's what we're doing here. So, I always tell people, how fast would it be for you to kind of do some analysis of that and some structured data? So, here's an example of let's select my warehouse that I'm using here, and let me select my database. So if I wanted to, obviously it's DDL, create table as, I created it, and then I inserted some, it's a state table, state dimension. So let me insert those 52 records for, the 50 states and, DC and Puerto Rico. Hello? Oh, it's the warehouse is resuming. It's not ready yet, so it's going to sit there and wait. Of course, this is the day that happens to me. All right, so I'm like, 99 for 100 now, going off script and everything working great. Anyway,
hey,
I'll come back to that. I'll come back to that later.
Okay, what are you measuring for each of the states?
So all I'm doing is I've got that data set of complete made up data of IP and state and time and just I want to bring some structured data and some JSON data together on the fly. Mm-hmm. And what this would be doing is saying, after I create the table here, I want to show you look, here's the 4,000 records, the 5,000 records. Mm-hmm. Let me create a 1-column table to house it. Let me load it, and it should take about 40 seconds to load all of that data, about 5 million records. And then I just want to do a select count star against it, right? And let me select data from it, and let me walk the tree of those elements in there and see how easy it is. And then put a view on top of it so that some downstream BI or ETL tool, it doesn't know that it's looking at JSON, but it looks like a view, and so it works just fine, right? And so we can always take a shot at looking at that. Of course, I should have known that was going to happen today. Anyway.
When you resume a virtual warehouse, does it rebuild the cache? Or is
No,
that-
it does not. Now, technically, you might get lucky. So the answer is no, but you might get lucky and get the same server that was there before, and if the cache is still there, you still get it. So if I were to drop that cluster, drop that warehouse, right? It's gone, but then an hour later create it again. It's in the pool yet, and that's one of the things that I'm not 100% perfect on. Some of our ops guys know this better, but how the pool works and how we keep servers in the pool for customers and things like that. You might get lucky and get the same one.
But it's not EBS backed?
No. Once it's deleted from the cache, it's gone. It's gone. Done.
If you're ingesting data, are you ingesting it from S3 to S3?
Essentially, yes. Essentially what we're doing is, so when we bring data into our database, we store it in what are called FDN files. It's a format that we created that our database uses, right? It goes into that format. Don't worry, once your data's in there, it's not like it's stuck in that format, like it's locked in. Our copy statement is bi-directional, so I can export data back out. So I can get data from S3, right? And when we store in our database, behind the scenes, yes, we're storing it in S3, right? You can load from a private S3 bucket, or if you don't have one, that's okay. I mean, again, if we didn't tell you about AWS, whatever behind the scenes, you wouldn't even know anyway, right? But if you don't have a private S3 bucket, you can utilize a Snowflake's. You get a user stage, a user account with your account. You can utilize that to upload data up into it.
And David, correct me if I'm wrong, you weren't an AWS customer prior.
We're not, we're using the Snowflake bucket.
Yeah, so
Yep.
Oh, is this, let me refresh this here. Is it started? It says it started. Let me give it a shot here. I just want to see if it started or not. So here, let me, so yep, it's available now. So just to see here, so if I do this, I'm looking at my, there's nothing in there. At JSON challenge here. It would help if I'm fat fingering, maybe I shouldn't go off script now. There we go. So here's the 4,999 files that I have out there, right? They're just all of that document here. Let me just do this here. So I'm just going to create a table called JSON table. It has one column in it. I do a select count star from it. Obviously, I should get 0 because there's nothing in there. But if I try to load it now, right, with this copy statement, and I'm going to have to load it from my challenge folder that I have here. And I'm just saying, hey, the file format, by the way, is JSON here. Real simple to load the data as is. I've got all those raw JSON files sitting out there. It's loading it as is. And so this will take about 40 seconds or so, hopefully. Again, 5 million some JSON records, 4,999 files. Just bring it in as is, and then I can start writing SQL directly against it. So like select count star from JSON table. Let's just, okay, it's done. I just loaded everything here. Select count star, there's my 4.9 million records. If I just looked at 1,000 records, I'm just saying, hey, select some of these fields here, right? This is the actual JSON that, and again, this is all made up data. Don't worry about anything here. This isn't like any customer data. It's just made up nonsense, right?
Latin?
What's that? There's no Latin. No, it's English. Oh, actually, it's using,
It is.
Ipsum lorem.
yeah, Ipsum lorem, right? All that good stuff is in here. But I've got, different records with different numbers of arrays in here. Like this one has 2. Here's one with 1 in here, right? Things like that. And then all the other parts that I parsed out, right? And so, for example, down here, I can cast out those data types to whatever I want. And so here's 1,000 records I'll look at where I've said, using a dot notation, look at those elements, and then I cast them as certain, certain data types here. And then, of course, at the end, I've got this array of varying sizes. Here's one with 1, 2, 3, 4, 5. Here's one down here with 1, right? Now let's say I want to flatten that out. I've got this SQL statement that just uses a lateral flatten. Again, I'm working on this data as is. I'm not parsing anything out. I'm not flattening anything. I'm not duplicating the data into another set. I'm not writing any, crazy stuff to parse things out. I'm just writing it as is here. This dot notation is easy to learn. Here's 500 records where I've just actually flattened out. So here's one that had 1, 2, 3, 4, 1, 2, 3, right? The Roosevelt. Roosevelt. Oh, there's Vita and Wesley. How about that? Okay. Here's one with 2, right? There's the 2. Here's Rhonda has a 4 or 5 in here. Yep, there we go. Right. So I just took an array and made it into rows. If I want to make it easy for the tools, again, here's where I just did. Let me make a view on top. Create a replace view with the SQL underneath it, and that's all I'm going to do here. I've just created the view, and now when I describe the view, so to any calling application, it's just going to look like a table, right? Now, if I did select distinct city from that view, again, I'm writing SQL against 5 million JSON records, 578 distinct cities. Which IP addresses are associated with a certain comment. So I am doing some text searching here. We are not going to tout ourselves as like a Solar or Lucene or anything like that. But if we have small comment fields, this one has every one of our comment fields here. I think I made it 50 words, whatever it is. But I can look like, again, through 5 million records, there's my 721 returned. Let me add NUNC here. There's my 7 rows from reading 5 million records. And I'm using an extra large cluster.
And those are all nonsense cities and states?
Yeah, so you're going to get like Lyle, Arkansas. There's a Lyle, Illinois, right? Colfax, DC. No, it's all garbage.
Right.
On purpose. I'm not a bad ETL. And then again, ANSI standard SQL. So this is what I tell people. Now, for this SQL statement that I'm running here, there's a much better way to write it. I purposely wrote this horribly, right? But again, I want to do a with clause to get data from that state table. I'm doing some math in here. I'm doing a window function on last value here. I'm doing some min and max stuff and some rounding, partitioning over a window. I'm doing a sub-select in here, and I'm using ANSI SQL where I can just group by numbers instead of column names, things like that. If I run that, again, on 5 million records, all JSON as is, it returns. So
what if you did want to persist that for performance reasons? Instead of doing the JSON expansion on the fly, you don't want your BI tool to have to incur that cost every time.
What cost?
Well, it's some processing, right?
Nope. So as we ingest the data, we're interrogating the document and storing it columnar compressed. So reading JSON is as fast as reading structured data. This is different. You're going to see a lot of other databases. I know Redshift, for example, right? And plenty of other databases are starting to tout, hey, we can read JSON natively. And it's true, they can. But if you read the fine print or look at the online forums, they're like, yeah, everything's great when it's 1 million records. You start getting it scaled, they're like, yeah, you should put this out into flattened out tables for better performance. We don't have to do that. When we load that data, we're keeping tons of metadata about all those documents, stored columnar compressed. It's just a view. It's not a materialized view. It's just a regular view on top. So, and then just one thing real quick here. I want to put reporting on this, right? So I want to attach MicroStrategy to this. I'm just going to download, and I'm getting my JDBC or ODBC drivers, a Python connector. We have a Spark connector. Node.js is new. All that good stuff too. So.
And you just pointed at the view, the ODBC, MicroStrategy, to architect the view directly, and you don't have to physically make the.
Yeah. We use a native connector, right?
Yep.
Yeah, there's a native connector. We have. Yep, absolutely. So that's my story. I'm sticking to. I will say, in my 18 years, like I said, this is the coolest database I've worked on so far in terms of the just capability. And again, I think back to the weekends that I lost thinking about indexing strategies and how to meet certain windows, right? And now it's like tear of joy. There was a question over here. Yeah.
How do you do the costs of
how much I'm consuming and things like that? Let me log in as, there's an admin tab. Let me log in as Demo 7 here. And if I log in as admin, I actually haven't logged in as admin in a while. I hope it didn't change the thing. Okay, now I'm in. There's an admin tab when I come in, an account tab. When I look at this is where I have users and roles and billing and usage. And so this is where I can look at, number one, here's my storage, my daily average throughout the month that we use for billing on storage. And then here's the tab for compute that breaks down by warehouse, in other words, by cluster. And so we're not at the user level yet. That may be forthcoming, we'll see. But right now, because I have role-based access control, who has access to use what compute clusters, I now know who's consuming credits, right? So I know that I give Kerry access to the ETL warehouse. He's eating up, 54% of my credits, and then I call him, hey, what's going on, right? Why are you always using an extra large and leaving it on all the time? Things like that, right?
It's super expensive, isn't it, David?
Yeah, I can't use.
Unbelievably expensive.
So.
Sarcasm.
Yeah, right. I was gonna say, throw a hashtag in there, just so everyone knows.
So the database in Snowflake, that's raw source data, right? You don't ever persist that into a more analytically oriented model in order to drive performance. You're always going to be doing that
Correct.
on the fly.
I'm not at the behest of a star schema or materialized views or projections or anything like that to extract performance. It is going to be as is. You're using a combination of a couple things. MPP is one. The other one is we are using some result set caching that we're doing so that it's smart about like, hey, you already ran this query, none of the data changed underneath, so here's the result set again. And the optimizer we've built from scratch, which is no small task. It's no small task to build an optimizer, and we did that very well. So I don't need a certain model to get performance out of this. I will say, speaking of modeling in a different context, there was quite a few hands up for advanced analytics. So I've just used the ODBC connection in R, right, to just use our ODBC to connect directly to Snowflake. I did some real rudimentary, I'm not a data scientist, I just did some Pearson correlation of weather data and Chicago crime data. Like, is there really a relationship? How strong is the relationship between violent crime and weather, right? And it's summertime, murders are going to go up. Well, they do, and actually, though, the correlation isn't as strong as people think. But again, correlation versus causation, I don't want to get down a rabbit hole there, but anyway. So thanks a lot. I hope you found this interesting. If you want to talk more about it, let me know. But I like when the customers talk about our stuff because it's cool. They're like, yeah, it works just like what he said.
Yeah, when you said you don't use star schema, that's not what makes it fast. Well, we told our CIO that's what made ours fast.
Okay, all right. Well, listen, I'm fine with it. You can still use the star schema. I'm still very much a fan of star schema. It's just it used to be for two reasons. Number one, business continuity, and number two, for performance. Right? We don't need it as a prerequisite for performance anymore.
How do you make this big?
Oh,
I made it go
wrong
away.
Oh, here. Did you bring up pricing?
pricing. Yeah, perfect.
The green button.
Talk about pricing for me, Dave.
Yeah, we haven't even looked at our costs. At least I haven't. Asked Ken today. We looked at how much we've been spending.
You guys are underutilizing right now, actually.
I know.
You guys are doing great.
So we're an insurance company. You can read the slide here. This was approved by our marketing department. Our team, our data warehouse team, there's how many, Ken? Ken, are you there? You awake yet?
Yeah, there's 5 of us.
5 of us right now. There's myself, David Stamsta, Ken Wood, the manager in DBA. We have Carl Van Hue, who's a ETL architect, and Lisa Madigan, also in ETL, and then Larry Souther is also in ETL. We're based here in Middleton, and we have offices in Connecticut as well. And New York City and Virginia. And
didn't it go by another name originally?
Yeah.
Capital Casualty or something?
It was Capital Indemnity.
Okay.
Yeah. You might be thinking of General Casualty, but that's a different insurance company out in Sun Prairie, Winterthur, which 2 of our team have worked there before at Winterthur. and actually used a different BI tool. Not MicroStrategy, but Cognos. Sorry, Michael.
That's a lot of money.
Yeah. All right, how do you make it go next and just enter? There we go. So this slide, the challenge really was we needed to improve the performance of the legacy data warehouse. So like you mentioned, we used to have a different name to the company, so we had all new management in. All the old management went away. The MicroStrategy implementation we had was about 10 years old. And the new people coming in didn't understand the reports, didn't understand the data, was wondering why it was so slow. And whenever they went in to do exploration of the database, they couldn't figure out what was in it, and they'd get back wrong answers, and it took all weekend to run the report. So the heart of it, the heart of this slide, just to make it quick here, was that we needed to improve the performance of the legacy data warehouse, and we needed to do it without any cost. We came up, Ken speak to some of this. We came up with some solutions other than Snowflake, but did you have anything to say on this one, Ken? I can't remember.
No, you go this.
Yeah.
Go to the next one.
Yep.
Oh, I'm sorry, the one you just, I did have something on that.
Is it shift?
Last one.
Oops. No. How do you go back?
Think upper.
Up arrow? There we go. There you go.
Yeah, so at the beginning of our, as the new CIO came in, we were getting more and more pressure to put more and more users on our warehouse, but the complaint was that it was too slow. And so we started looking at, well, what's causing the slowness? And we isolated it to the database itself. So from the user perspective, they think the BI tool's slow, but it was actually the database. So what I looked at the database platform and how could we increase the speed. Let's say we wanted to double the speed, but the direction was also we don't want to spend a lot more money. And just our in-house database platform, which is a very well-used industry leader database platform, just doubling that platform, just doubling CPU and memory would have cost $500,000 in licensing. Not counting hardware, but just licensing itself. And would have given us maybe 2 times the speed. And so those things were like things we considered. We looked at other cloud options even to see if they would save us some money, but they didn't really offer increase in speed. So these are the kind of things that we were looking at the beginning.
Yep.
You go.
Yep. Serve the data analyst quicker was at the center of it. So we knew we had the data. It was the perception was MicroStrategy was slow. We discovered that the underlying database was what was causing the issue. We were using MicroStrategy for the most part to download.
So this is kind of the overall picture of what we had before. And I kind of spoke to it already. We were concentrating on the database itself as the bottleneck. So I don't have a lot more to say. Just that was that was where our bottleneck was. This is the before picture.
Yep. He had some of the challenges where he looked at where the upgrade costs he mentioned already would be really expensive. When we first heard about Snowflake, I was mad. I was actually, first I thought they were lying to us. I thought, oh yeah, another sales guy telling us it's really fast, telling us all that. And Ken's the one who actually brought them to us originally. You saw a demo at a Gartner seminar somewhere, Ken?
Yeah.
Yeah. And then we loaded it with the CSV files. And I don't know how long that first proof of concept took, but in a matter of days, we had MicroStrategy pointed at it and de-optimized from our existing warehouse implementation. because we had to, we'll talk about that in one of the other slides, but I thought he hadn't loaded the data when we first saw it. I actually thought he hadn't loaded the data. It came back so quickly. Yep. No indexes.
By the way, the feeling was mutual when I heard
Yeah.
your first ones. I told Carrie, I'm like, they didn't load, they made a mistake.
Yeah.
I was expecting like 100x performance improvement, and they got even better.
We were using a small, I think,
Yeah.
smaller, extra small at first.
I was like, no, they made a mistake.
Yeah. Yeah, so that's really the heart of our story amongst all some of the other stuff, but that is really it.
How far away was the physical vault that you used? No, on the previous slide, it said physical vault, storage vault.
Oh, this is kind of a slide of what, a normal architecture might have
I
to
see.
do. The disk that we had and the storage, I don't know, where do we keep our offline storage, Ken? And the online storage, and we have a SAN.
Yeah, I don't, another team takes care of that stuff, so.
Right. I'm going all over the place here now. There we go. Enter. There.
Just a different view of the before and after.
Yeah. So, in a very short period of time, after doing the proof of concept, we got buy-in from our CIO to do the migration, and we purchased it. And Ken's job was riding on the line, so is mine. And mostly Ken. I mean, Bob let him know too. This is going to work, right?
Sorry.
Yeah. I was optimistic and confident, and I would just find another job, I guess. Right.
Yeah, everybody was skeptical.
Yeah.
When did you guys start the POC?
I look
So
at
the
that.
biggest challenge we had to migrate was in the custom development of the ETL, because we didn't have, there's no interface out of the box with Snowflake, so, and they do have some bulk load drivers and stuff like that for different ETL tools, but for the tool we had, there wasn't one yet. So we had to build our own ETL tool to load the data up, basically generate DDL for Snowflake, create the tables and load that data. That took a few weeks to develop, and then loading the data is just a matter of minutes.
Yeah, we did the POC, Carrie had asked when we had done the POC, I think it was back in October. And then I think we spent like two weeks. I had the actuaries. I had a copy of MicroStrategy pointing up at Snowflake, and had the actuaries go through and run their hardest queries against it and prove it out. And so in less than 2 weeks, we had that acceptance testing done. And then Ken did what he just said there. We got approval, and he started writing the ETL. That took a while to figure out that part. That was probably the most difficult part. And then the MicroStrategy component. So after 10 years of the implementation, it had been highly optimized against the incumbent database. We had everything configured in these VLDB settings, very large database settings, to some of the queries in MicroStrategy. It generates multi passes of SQL, some of them 150 queries at a time, go against the database, create temp tables, create indexes against those tables, run stats against it, all configured inside of the MicroStrategy tool. I had to remove all of that configuration, so it would just run. And we use global temporary tables in the cloud, so we don't incur that extra cost of the storage. At least I'm pretty sure we don't. I haven't looked, but we're underutilizing. So the tables get created and get dropped at the end normally, but when you use global temporary, it doesn't. It just leaves it and it's gone. It's not part of the cost, I'm pretty sure. I read it in help. So maybe I wasn't supposed to say that they're free, but they're free.
Go ahead.
Yeah. So those were some of the configurations we had to just undo in MicroStrategy to make it fast.
Yeah, so I'll talk about the first two challenges. The first one was kind of minor. We ran into a few data type differences on how our incumbent database handled certain data types versus Snowflake. For example, in our incumbent database, the number data type defaults as a float, but in Snowflake, it defaults as an integer. So we were getting truncated data for fields that didn't have precision defined in the data type. So that was pretty simple to work around, but those were a few hiccups we had to run through. And then there was a date to timestamp conversion, that kind of thing. The biggest performance issues we saw were when people wanted to use non-MicroStrategy reporting tools. So we did a lot of evaluation of different tools because some people want to just run straight SQL, and I didn't necessarily want everybody out on the cloud yet using the worksheet. So what it came down to is it really comes down to the tool. Snowflake Speed is meant to provide massive amounts of data in parallel very quickly. But if the tool can't handle that, if it's a serialized tool, it doesn't perform very well. So tried hooking up access through ODBC, and it didn't run so well. I'm sure there's ways to tune it, but it didn't run so well. But found some third-party SQL tools that just really worked well. And so what it really came down to is that they were designed to handle parallel connections through ODBC or JDBC. They ran well.
Yep. We had a custom web portal that it doesn't perform well. It's a small set of data also, but it, just milliseconds up on the cloud, you can see the queries hit, but it takes a long time to come back to the machine and render, at 2 to 3 seconds, which is a long time. So I think we've overcome most of that now, actually, in working with the developer on the web page. So,
and a lot of that was designed. They would build a connection for each query.
Yeah.
So it was just kind of a bad design.
Yep.
Did moving from ODBC to JDBC help that?
Yeah. From what I understand,
it
did. Yeah, it did help it. Yeah, we removed a bunch of I had about 50 pages of MicroStrategy notes that I had made when I was doing the configuration in the development environment, and then moved it to acceptance, and then eventually to production, just to undo all the project settings that were optimized from before. So in MicroStrategy, it generates dynamic SQL, and it uses column aliases in the create table statements, and some of those create table statements had column aliases that were sized to 100 varchar to 100, and the actual data was 200, and it was throwing errors when we started going through the data here, but it was really easy just to change it in the metadata in MicroStrategy. Had to use some apply simple functions. Does anyone here use MicroStrategy at all besides me? No, I'll skip it then. Next. So the EDW in the cloud, the on-premise warehouse, we had, of course, tons of indexes, the star schema, Snowflake, all kinds of optimization and analysis stats run on it all the time. In the cloud, none of that. All that just goes away. You don't have to do anything. Literally, you don't have to do anything. I mean, I know it's, again, this is what just makes me angry. I think of how much of my life, Ken, how much of my life I have spent
for what it's worth.
looking for indexes, doing, analyzing stats on tables. I mean, Ken's the
I think the most work and setup was security.
Security in the roles, setting up the roles.
One comment I wanted to bring up with the cloning, which works really well, is it carries over your permissions from your database that you're cloning from. And maybe Brad can speak to that later. But so whenever we would clone databases, in a few seconds you've got a new database, but then you got to run scripts to re-grant your your permissions for the roles for that database.
Yep.
That would, depending which customer you talk to, some people think that's absolutely awesome that it does that, and other customers are like, well, now I gotta redo it for that, right?
So
'Cause
protection.
you can make the, what's that?
Yeah.
You can make the argument both ways.
Mhm.
Of why, do I want the security to keep going through or not? I think, so we landed on, it does, and if you gotta rerun a script for just redoing the grant and revoke, right? I guess we'll probably
Worth
revoke.
noting on the security front is that end-to-end encryption is just built into our solution. So there is no active versus deactive. It's just in flight and at rest via AES 256 cipher blockchain encryption, and there's no performance hit to encrypt data in Snowflake. And then our friends at CapSpecialty are complying with HIPAA with our solution, so we can produce our SOC 2 type 1, type 2, and HIPAA reports of that.
They're HIPAA compliant. We have some HIPAA data, at least we were worried about it, so, because we do medical malpractice insurance also in some of our companies. And the claims data has HIPAA data, so they're now, that was in the contract that you had to be HIPAA compliant by January, I think you were.
Yeah, we did the deal in October, and it was by end of Q1, we had to be HIPAA compliant.
Yeah.
Yeah.
So this slide shows the benchmarks before and after. I picked the BBRs represent a whole series of about 70, 100 different reports and analyses that get run on a monthly basis. Time shown in seconds. So the total run time of all these reports, you can just see the difference there, 123 times faster. This is extremely significant. So then after 3 months, these are the results. So I took it, did analysis on using Enterprise Manager, looking at the queries run in the Q4 versus queries run in Q1. And both quarters have big hits on data. Q4 is just before the end of the year. Q1 is after the year is through, so everyone's doing analysis on the data. But you can see the query performance time. So what this led to, the connection here is that the company was growing, we had changed. They were coming up with new lines of business, new product lines, and the actuaries were doing analysis on historical data to achieve pricing for these new products. And then the policy origination system was being configured with these new pricing algorithms and to start writing this new business. And now they want to show the results of it, of that business. So having Snowflake allowed the business to get this much quicker. And it even allowed it to happen, I think. We're just a small part of the team. There were hours and hours of meetings on the new business lines, and we weren't involved in any of it, but the time saved in getting the analysis for the queries is amazing. And that really that is the story here. It's made our team kind of the stars right now, the company. It really has. Where before we were like the goats, like, wow, why can't we get anything out of the data warehouse? It's useless, why do we even have it? So it really was that bad. I'm not exaggerating, am I, Ken?
No.
No. Unfortunately, I'm not. So, yep, this slide kind of says that. Performance improvement, 21% increase in usage, and that's from 6 different actuaries. So not that many people, actually, but just a much more, a big increase in the usage and reduction in time. So the end user testimonials, I took these when I did the proof of concept, and it's transformational, all the way down to I didn't really notice a difference, right? And so that one was one of our most skeptical users anyway. So I called him up and I said, "Oh, what were you running?" And I looked at it, and it was just this tiny little query, right, going against an aggregate table. So MicroStrategy is aggregate aware, and we have these big, large base tables, but then we build aggregate tables and maintain them and keep all the indexes and build them as part of the monthly flow. Well, when I looked at that, the work we did in Snowflake, we actually got rid of all the aggregates. So we don't use any aggregate tables anymore, so we don't have to build them out. And it was actually going against the base table. The actual query was going against the base table and summarizing it, kind of like some of the stuff you had shown there. So that one is actually probably the most phenomenal remark. Actually, he didn't even notice a difference, and it's using a completely different infrastructure where we don't have to maintain it anymore, which saves us time, which allows us to bring in new sets of data more quickly. That's really the heart of the story there. So the two on either side here, on the left and the right, the daily refresh of the data warehouse is our effort right now, and then MicroStrategy Mobile, allowing us to connect to the cloud mobile. And I just was showing Michael what we had just done. Just today, actually, we upgraded to MicroStrategy 10, and we've got a mobile instance out now. Showing real-time data against the cloud data warehouse, which is not quite real-time, but yeah, what are they now? It's every 15 minutes. It's updating every 15 minutes. And I had shown it to one of the leaders of the company. He was out, we had agents in last week, and he was walking around giving agent demos, and he stopped by my desk and said, "Do you have that mobile ready yet?" And I goes, "That's not quite ready." I showed it to him again, and he said, this is inspirational, and this is just, what was the other word he used? It wasn't just, something beyond inspirational. But what it did was, there wasn't a lot of business value in just what he was seeing, watching new submissions, new quotes, and new policies come in the moment. It was that these were all new product lines. So he could show it to his team and see, look what the work we just did. And we're starting to be successful in these new lines of business, and you can start seeing when you turn the phone sideways, it turns into a time series, and the lines stack up against each other, and you can see it growing. So that was the visualization of that data on his iPhone was important. Oh yeah. So this is from the 60s. But, yeah.
It's still popular.
It's still popular. So this was MicroStrategy and Snowflake together. So they do have a data connector right now for Snowflake. When we first did the POC, I had to use the generic data warehouse, so I had to do a bit more tweaking to some of the VLDB settings, but now I actually have been undoing those, and we're using the connector that comes with MicroStrategy. And like Ken had said earlier, MicroStrategy seems to work really well with Snowflake. You can go out and do what Brad was doing and type in queries directly into there, but you can also use a tool like MicroStrategy. That's it. Any questions? Do you have anything else, Ken?
Nope, I think we're good.
Okay.
Any questions? Otherwise,
Any questions?
are you guys going to come further?
Yeah, you can twist my arm.
Yeah.
Sure. Does anyone believe any of this, or is
Yeah.
everyone like, these guys, they're colluding?
Yeah.
They're conniving.
It does sound like that. But yeah, we didn't get anything for doing this.
No kickbacks?
Not even a discount?
Yes, sir.
No discount, but you don't need a discount, really. You don't need a discount.
You have a question?
I mean, it's,
Just more of just an add-on and everything else that relates to the relationship that we have here. I'm with MicroStrategy. We're an enterprise analytics platform for both self-service and predictive analytics along those lines of stuff. Just wanted to put a pitch out there. It's a very powerful tool. There's a free download. It says 30-day trial on the website, but really there's no 30-day limit to it. So I encourage you to download it for some just visual discovery and play with your data. It's pretty powerful stuff.
there's over 300 statistical calculations you can do in it. It connects into R, as well as you can use the R in Snowflake. And I did a demo of R for our actuaries, but they don't use it yet. But go figure.
One comment I wanted to bring up that I forgot to mention was that our POC was configured at the small setting, and we haven't had a need to increase that.
Yeah, every once in a while, Ken, I confess, I run up to a medium sometimes. When I-
Yeah, and we have one of our
Can you turn
virtual
it up
warehouses set
run
to
24/7?
medium for ETL.
Yep, that's what
But,
I,
yeah.
yep.
So as small as our second smallest cluster, it's a little 2-node cluster in our compute menu. And then along the lines of the free trial, so we'll do bundled offers where MicroStrategy will offer, the free trial in conjunction with Snowflake. We did a full POC at no cost with CapSpecialty, right, guys? I mean,
Yeah.
there's no cost for the POC for them. And
Yeah,
no
we had-
obligation. So they signed on to our MSA and everything like that. And if things didn't work out for them, they had full rights to terminate at any time.
Yeah, it just would have been, Ken and I would have been looking up for a new job at that point. Yeah.
So you mentioned the statistics on the number of queries and the speed, and those are all very positive. You had made a comparison to your incumbent in order to scale that out. It was going to cost a whole bunch of money, and it was only going to
half
be 2
a time.
times faster. And that was going to be a lot of money.
I can't hear the question.
I'll repeat it.
Yeah, so when you moved to Snowflake, without going into actual numbers, can you make a comparison about costs? Because you've been mentioning costs a little bit.
So he's asking if we can make a comparison of costs to Snowflake compared to what we would have done,
Or no, compared to where you were.
compared to where we were. So we're still paying for the database we have right now. Yeah, our incumbent database. We're
But
still,
you're gonna sunset that.
Yes, eventually. Yep, that's the plan. To sunset the
So I guess in that case,
incumbent
since you are
database.
still paying for it, why don't you talk a little bit about the incremental? Obviously, you're not up to 2x, right?
No, can we talk about how much our contract is for? We don't want to say that.
I would say it's safe to say that overall TCO, we were, over the next 3 years, we're more than 80% less than,
Yeah.
more like 90% less than their incumbent.
I would say we spent a fifth on Snowflake of what we were going to spend on the other just to get 2 times the speed.
Yeah, that sounds pretty impressive.
Yeah. And we're, as Brad mentioned, he must be looking at our stats, but we're underutilizing right now.
Yeah.
But we have
We're
more,
using about 4% of what we paid for.
yeah.
Well, and if suddenly you're in a month where you're just doing tons and tons of analysis for whatever reason, because of the elastic nature of it, you can just crank it up.
Yes.
At the end of the month, bring it back down.
Exactly.
Right. And
You
and we
couldn't do that with your incumbent, right?
You can't.
No.
Nope. And I don't feel bad about loading in tons of data just to see what we have quickly, right? It's okay. You can just spin it up and we have playground environments that we can turn off, turn on.
Well, another thing is the compression is really good, the automatic compression and the security, the in-flight and at-rest encryption.
The real world compression that you're getting is about what, 4 to 5x?
The real world compression.
Yeah. What are you seeing in total
Oh.
compression?
Wow. I don't know if I've even looked.
Okay.
Yeah, I just know it looks really small when it's up in the cloud.
I know we knew.
That's 'cause it's
That's why
Talking about storage?
Yeah, storage, what the compression ratio is.
Out of mind.
Well, we've got 3 databases that would be 300 gigs each, and we're using total 50 gigs.
Yeah, and
So,
Whatever that is.
does that include all the indexes and all the other?
No, that's without indexes. The indexes, by not using indexes, it's about a third
yeah.
of the space saved.
And you only pay for what you consume after compression in Snowflake, so storage is frankly, we say internally, we just call it peanuts.
Yeah.
Peanuts.
Yeah, it's the compute, if you keep the
Yeah.
warehouse up
Yeah, you
and
can,
running.
if you're in a
24/7.
large cluster and you're running in 24/7.
Yeah.
You might chew up a decent amount of money, but that's the.
We've got a small 24/7, and then we've got an extra small on demand, but I've changed it to
Yeah.
a small and sometimes a medium.
That's the advantage of our architecture, decoupling the storage from compute. You're allowed to save on costs, right? Because you only have to run compute. We could turn off our clusters without having to unload data and turn back on without having to reload data.
I hadn't really seen the JSON demo yet. Did you see that, Ken? Had you seen the JSON demo? You hadn't
Oh,
seen?
not before.
No, not before, but I know our CIO keeps hinting at using JSON. Isn't that what everybody uses? Shouldn't we have a schemaless database?
I heard that,
I
everyone.
hope he's not listening, but really, he has mentioned it. And
What's his name again?
Yeah. So have other people in the company, just 'cause it's a buzzword, people hear about
It's
it.
becoming, it's reaching critical mass. It's showing up in too many places to ignore it now. It's becoming a de facto standard for Internet of Things. You know, if you're gonna be getting stuff off devices, more and more of it's gonna just be in that format. Until, someone comes up with a new standard, right? And whatever, right?
So with this, we're able to tell them, yeah, we can do that. Our team can do that already. We have Snowflake in place, and we'll have to learn some JSON, but we can still use SQL.
Yeah, writing SQL, the dot notation. Listen, if I can figure it out, you guys can figure it out.
The last job I had, we had to use JSON, but this is much better.
Yeah, I like this over like Mongos and things like that.
Yep.
Because I was always a SQL guy. I wasn't a programmer, right? So the other thing I just mentioned about the clusters too, and people do worry like, hey, can I let the size get out of control? You have to be explicitly granted permissions to create these clusters and turn them on and operate them. Because again, if you just if it was just out of the box, everyone had access. Everyone's XXX large, not all the time, right? Not that Carrie won't enjoy that, but you have to be explicitly granted. There's governors in here to make sure the auto suspend is. I've only had one customer so far to say that Snowflake, I don't know, it's difficult and it's risky because what if I forget to auto suspend my stuff? I don't know how much easier we make it than auto suspend.